Hello Year 6 and welcome to today's arithmetic video. Just a quick reminder to please have a go at the questions before we begin. That way you can use this video much as you would in school to share strategies and to check your calculations. Now as we go through, if you've noticed that you've made an error, please pause the video and use the video to help you edit and correct your work. Okay, I'm not going to remind you to do that after each question today. I'm going to trust that you're managing that for yourselves and that you don't need me to remind you. Okay, so question number one then. 1,802 multiplied by 43. Now I've set up the formal column method of multiplication here. And I'm going to start in the ones with 2 times 3, which is 6. 0 times 3 is 0. 0 lots of 3 will give 0. 8 times 3 is 24, so I carry my 20. Any numbers that I carry in this method I record smaller, so that when we come to add the final two amounts together, it's much easier to do that. And 1 times 3 is 3, add the 2 is 5. So I've multiplied everything by the ones digit, and now I'm moving over into the tens. And to show that, I put my 0 or my placeholder in. It's now increasing this amount by 10, and it represents the 40 here as well. It's a good way of remembering it. So 4 times 2 is 8. 0 times 4 will be 0. 8 times 4 is, that's right, 32. And 1 times 4 is 4. Add the 3. That's right, Year 6, 7. Okay, so the final part of this method is to total the two amounts to give our answer. 6 and 0 is 6. 0 and 8 is 8. 4 and 0 is 4. 5 and 2 is 7, and nothing and 7 will be 7. 77,486. Hopefully you're in agreement and you're giving your work a little tick. Don't worry if you're not, just pause the video. Okay, question number 2 then. I'm just going to bring down here so we've got a little bit more room. We want to know what 2/5 of 30 is. Okay, well to begin with, I know that I can find 1/5 of 30 by dividing by 5. So 30 divided by 5 will be the same as 1/5, and 30 divided by 5 is 6. So I know 1/5 is 6. Now if I want to know what 2/5 is, I have to multiply this answer by 2, and 6 times 2 is 12. Therefore, 2/5 is 12. Again, if you're happy with that one, give it a little tick. If you need to pause the video and rethink that strategy or the method, do so now, please. Okay, again, I'm just going to move this one down so we've got a little bit more room. Okay, 8,625 divided by 25. Okay, looking at this one, I'm going to need to use the long multiplication method. I'm going to start by thinking 25 into 8 doesn't go. Now I'm thinking 25 into 86. Well, I know I can count in 25s really easily actually. 25, 50, 75, 100. So the closest I can get to 86 is 75, which is 3 times. I'm going to record 75 under here so that I can find the difference or the remainder. And to do that I'm going to do a subtraction. So 6 subtract 5 is 1, and 8 subtract 7 is 1. Okay, so now I'm thinking 25 into 11. That doesn't go, so I'm going to bring down another digit, or the next digit from my original number, 112. Okay, well let's think about 25s. I'm counting up in 25 here. The closest I can get is 100, which is 4 times. But I need to know what my remainder will be. Well, actually I could probably do that mentally, but we're going to continue with this method. Let's move that bit right out the way for us. Okay, so my remainder, 112, subtract 100, I know my remainder is going to be 12. I've got to bring down the final digit of my original number. I'm thinking 25 into 125 goes 5 times. I can check that over here if I need to. So 345. Hopefully you're ticking your work now in agreement. If you're not, please pause the video, take your time to have another look at that method. Okay, question number 4 then. I've prepared over here for us. What I'm going to do, year 6, is I'm going to rub out this long division. So if you still need it, please pause the video. Don't know quite what's happened today. We seem to have run out of room. So let's put this one over here. We've got plenty of space. Okay. So 2/3 add 4/6. Now, because I'm adding, I know that the denominators, or the bottom numbers, must be the same before I can add. So I have to convert these fractions into equivalent fractions, so fractions that are worth the same amount, before I can add. Now I'm looking at the 3 and the 6. I know 3 multiplied by 2 will equal 6. So therefore, I'd have the same denominator on each fraction. Okay, and then whatever I do to the denominator, I have to do to the numerator, or the top number. So 2 times 2 is 4. So therefore, I've got 4/6 add 4/6. I didn't need to convert or change this fraction because it already had a denominator of 6. Now the denominators are the same, I can add them together. I never add the denominators, they stay the same, but I do add the numerators. So 4 add 4 is 8. Now I'm going to ask you to look carefully at that fraction. What do you notice, year 6? Brilliant, it's an improper fraction. Now I know that 6/6 is the same as 1 whole, and I could create 6/6 from this fraction. That would leave me with 2/6 remaining. Now if I'm looking at 2/6, I know I can simplify 2/6. My 1 whole remains, but I know that 2 goes into 2 once, and 2 goes into 6 3 times. So therefore my answer is 1 and 1/3. If you left your fraction as an improper fraction, don't worry, year 6, but do pause the video now and have a go at simplifying this fraction, please. Okay, I look forward to see how you got on that with that one on Class Dojo, because we've not done improper fractions for a couple of weeks now. So, question number 5. I'm just going to set it up again for us here. We've got 48,764 add 34,879. So as always, we're going to start in the ones column with 4 add 9, which is, that's right, 13. Now I can do 6 and 1, which would give me 7, and I know 2 7s are 14, so a little bit more of an efficient method. Again, I know 7 and 1 is 8, and I know 2 8s would be 16. So I'm just looking for those quick and easy methods. 8, 4 and 1 would be 13. Again, I know 3 and 1 is 4, and 2 4s would be 8. 83,643. Okay, that concludes the first part of today's arithmetic. If you need to pause the video and rewind, please do so now. Right, the second part then of today's arithmetic, we're going to start with our green question, which, as we know, everybody in our class should be able to do and feel fairly confident with. Okay, so let's have a read of the question. It says, order the numbers, so we've got to put them in order, starting with the largest, match each number with its order. So I've got my numbers here, and then we've got largest, second largest, third largest, fourth, which is the smallest. So I've got to match them up. Okay, well, let's see what I can notice first of all. I notice that they're all 1 million. So I'm going to look in the hundred thousands place value next. 0, 0, 0, 2. So that means that this one must be the largest because it is 1,230,000. Okay, so now I've looked at those. I'm going to just double check the hundreds place value again. Right, now I'm going to go to the 10,000s place value. 0, 2 and 0. So that must mean this one is the second largest. Okay, and now I'm going to look in the thousands column. So this one's got 9,000, 3,000, 9,000. So if they've both got 9,000, I need to check the hundreds next. 900, no hundreds. So this one must be the third largest. And then this one must be the smallest. Okay, hopefully you've been able to match those up accurately. Some of you may have found it useful, and if we were at school, I would be encouraging some of you to put your digits, or your numbers I should say, onto a place value chart, like so. This won't be a complete one, but you'll get the idea. Oh, that should be 10,000s. Okay, you get the idea. You can put the numbers on there to see which has the smallest amount of hundreds, which has the smallest amount of thousands. Okay, question number 2 then. Now this is an amber question, which again most people in our class will be able to do, bar maybe 2 or 3 people. But we are going to continue to be an explorer, and we're going to continue to seek challenges and show determination. And that means giving things a go, even if we think they're going to be a little bit tough. Okay, now I'm going to use UDC to help organise my thinking. So I need to underline and understand the question to begin with. I could draw some pictures, or I can see they've drawn a picture here for me, so I might add to this picture with some drawings, some doodles or some jottings, and then I can use those to help me calculate. Okay, so Layla makes jewellery to sell at a school fair. Each bracelet has 53 beads. She makes 68 bracelets. Okay, so I can see there's a bracelet here and some bracelets here. So I'm going to say one bracelet. I like to do jottings as I go through so I can see what's going on. Has 53 beads, but she makes 68 bracelets. Okay, let's look at the next part then. Let's try and understand the next bit. So each necklace has 105 beads. So one necklace equals 105 beads. And she makes 34 lots of necklaces. Okay, how many beads does she use all together? Okay, so I need to then do some calculating now to find out how many beads were used in the bracelets, in the 68 bracelets. How many beads were used in the 34 necklaces? Okay, so I know that there were 53 beads in one bracelet and she made 68 bracelets. So I know that I will need to multiply these together. I'm going to do that now. So 3 times 8 is 24. 5 times 8 is 40, that's right. Add your 2, 42. And you'll notice I'm deliberately pausing year 6 to give you a chance to join in. Right, I'm on to my 60 now. So 6 times 3 is, that's right, 18. And 5 times 6 is 30. Add your 1, 31. Then we need to add these two amounts together. 4 and 0 is 4. 2 and 8 is 10. We've got 4, 5, 6 and 3 on the end. So we know when she was making the bracelets, should have done that in purple really. Let's put a purple B there. I find it useful to have the colours. Bracelets, we know she used 3,604 bracelets, beads in the bracelets. Okay, let's have a look then at the necklaces. One necklace used 105 beads and she made 34 necklaces in total. So again, I'm going to do my calculation. 5 times 4 is 20, that's right. 0 times 4 will be 0, add the 2 you've carried. And 1 times 4 is 4. Okay, multiplied everything by the 1s, we're into the 10s now, the 30. 3 times 5 is 15. 0 times 3 will be 0, add the 1 you've carried is 1. And 1 times 3 is 3. So then we add together these, 0 and 0 will be 0. 2 and 5 will be 7, well done. 1 and 4 will be 5, 0 and 3, 3,570. We want to know how many she's used altogether, so I'd need to add these two amounts together now. Okay, and I'm sure you'll be doing this a lot neater in your book using a ruler and so on. There we go. So 4 and 0 is 4, 0 and 7 is 7, 5 and 6 is 11, 3 and 3 is 6, add 1 is 7. So our answer is 7,174 beads altogether. Okay, there's a lot of steps to that question, year 6. I have no doubt that you know all the methods for each step, so I hope you've been able to apply the methods this morning and that you've been successful. If you haven't, don't worry, because like I say, there are a few steps and I know that you can do each step on its own. Putting them together can sometimes be a challenge, and that's okay. Okay, so if you need to now, pause the video, have a little look at your learning, and then come back for question 3 when you are ready. Okay, so question number 3 is today's red question. And all that means is that it requires a little bit more thinking. Now there is some new learning in this question, which means some of us may need to look carefully at this so that we can find out what the mean is. So we'll start by reading the question, underlining and understanding. We'll do a drawing or a jotting. You can see they've got a drawing here to help us, so I might add to that. And then we can calculate. Okay, so last year, Jacob went to 4 concerts. 3 of his tickets cost £5 each. Okay, so we've got 3 tickets over here. This one cost 5, this one cost 5, and this one cost 5. So 3 tickets altogether will have cost him £5, £10, £15. So I can work that out straight away. The other ticket cost £7. So this one under here was £7. Now, if you didn't have these tickets here, Year 6, you could always draw them at home just by using a little square to represent the tickets, or a circle, or however you picture them is fine. Remember, jottings and drawings can really help us to understand how to calculate. Now, it says, what was the mean cost of the tickets? Now, to find the mean, we need to add up the totals and divide by the amount of tickets. So first of all, we need to do 15 add 7, because that's the 2 costs, and it will give us the total cost of the ticket. So 15 add 7 would be £22. Now, mean is an average. So to find the average cost of the ticket, we'll need to divide it by the amount of tickets there were. So 22 divided by 4 would be £5.50. Okay, now I know that lots of you know if you divide by 4, you half and half again to give £5.50. So the mean cost of the ticket was £5.50. Now, like I say, the mean could be new learning for you this morning. So don't worry if you've just watched the video and you're trying to take it in this morning. It is something that we're going to come back to, hopefully very soon when we're back at school together. Okay, so I hope you have enjoyed today's Arithmetic Year 6. Please share your learning on Class Dojo with me, and I look forward to seeing you very, very soon.